In section 5.5, we're continuing with what we looked at in section 5.4. So let's review for just a second the polynomial long division that we were doing in our last section. So if you'll remember, we were dividing something like this cubic by x minus 2, and we got this quadratic. When we did, we called that the factorization because if you take 30 and divide it by 6 and you get an answer of 5, then you would say that the factors of 30 are 6 times 5. So if I take that cubic and I divide it by x minus 2 and I get this quadratic as an answer, it's the same thing, right? I was dividing by 6 and got an answer of 5. I was dividing by x minus 2 and got an answer of this quadratic, so that if I multiplied these two back together again, I would get this cubic. And so in that way, we were able to take this cubic that we couldn't factor before any other way, because it wouldn't factor by grouping, and now we're able to factor that down. Another way that we did that same thing was with synthetic division. Now remember that you can only use synthetic division when you're dividing by something in the x minus k form, and it's going to be the opposite of this value right here, our k. It's like your solution. It's like this is your factor form, and if you solve that and got your solution of 2, that's what goes in your little box. Our coefficients went across the top. And when we did our synthetic division, the same thing happened. Like we could say, hey, this was x minus 2, and then this was the quadratic solution that I got. The other thing we said is that if you really didn't need to know the whole solution, you just needed to know the remainder, that there's a fast, easy way to find that called the remainder theorem. And in the remainder theorem, if you take your k value, so again, that's just the same value that you would put in your box. If you take your k value and you plug it into the function, the answer that you get will be your remainder. So for instance, if one of the problems we did was x cubed minus 5, and we were dividing it by x minus 1, so we put 1 in for k in the function, and it gave us our remainder of -4. The reason that was significant was if you get a remainder of 0, then that means what you were dividing by is a factor. If your remainder is not 0, then what you were dividing by is not a factor. So let's take that into what we're looking at today. What if they didn't give us the x minus 2 to divide by? What if we had to figure that part out for ourselves? And we absolutely can by using the real zeros of polynomial functions and the idea of p over q. All right, so what I'm going to do is I'm going to find the possible rational roots of this function. Okay, so let's think about what rational means again. Rational is something that can be written as a fraction, right? And rational is both non-repeating and non-terminating, and of course not imaginary or something like that. So if this polynomial has a rational root, I can find it by putting p over q. All right, what do we mean by p and q? Well, p are the factors of the constant, and q are the factors of the leading coefficient. All right, so first, I'm going to factor out any common factors that this might have. I didn't have any common factors for this one. And so then I'm going to find all of the factors of p. So that's going to be plus or minus 1 and plus or minus 3. Now, the reason we say plus or minus is it could be positive 1 times positive 3, or it could be negative 1 times negative 3. So plus or minus 1, plus or minus 3, and then the factors of my leading coefficient are going to be q, and so that would be the factors of 2, so plus or minus 1 and plus or minus 2. So if I put my p's over my q's, then that's going to be 1 over 1 and 3 over 1. And then it's going to be 1 over 2 and 3 over 2. So I would get 8 possible rational roots. Now notice we don't also put our q's over our p's. Now, are there going to be 8 solutions to this polynomial? No, because it has a degree of 3. How many solutions does that mean it's going to have? 3. So it can only have 3 solutions. Some of those might even be imaginary or irrational, but I should be able to get, if there is a rational solution to this polynomial, it is going to be in this list right here. All right, so I'm going to go through and I'm going to start plugging values into my function. Why would I do that? Because I'm trying to find the remainder, right? If I plug in my k value, the answer that I get will be my remainder. How does that help me? Well, if my remainder is 0, then I know that it's going to be a factor, right? If it's not 0, then I'm not going to waste my time with it. All right, so when I plug in 1, I get 0. Therefore, that means it's a factor. So that would be a value that I would want to do either polynomial long division or synthetic division with. So they didn't have to give me the x minus 1. That's how I can figure it out for myself. So I'm going to put my 1 over here in my box, and I'm going to do synthetic division. So I'm going to copy my coefficients across the top here. Remember that your 2 comes straight down, and then 2 times 1 goes in the next column. Combine those. 5 times 1 goes in the next column. Combine those. Negative 3 times 1 goes in the next column. Combine those. So now I'm going to go through and remember that this first power right here is always 1 less than what you started with. So this is going to be 2x squared plus 5x minus 3, remainder 0. All right, so now I have a quadratic, and I know how to solve a quadratic, right? So I could factor it, or I could put it into my calculator to solve it. So here's what I know. I know, just like we talked about before, that if I take 30 and divide it by 6 and get a remainder of 0, that means that that 6 is a factor of 30, and the answer that I get is also a factor of 30. So I can say that 6 times 5 is equal to 30. So same thing here. I just divided by x minus 1, and I got that quadratic right there. So that means that x minus 1 and that quadratic are both factors of that cubic. And again, I was able to break down a cubic that would not have factored by grouping. I didn't have any other way to break that down, but I was just able to factor it. Okay, so this is our factorization over here. So now to finish solving, I'm going to set each of those factors equal to 0. And the quadratic does factor. If it wouldn't factor, then I could do completing the square or quadratic formula to break it down. But this one does factor, so then I can set each of my factors equal to 0, and I'll get my solutions of 1, 1/2, and negative 3. All right, so those are all real numbers, so those would be my real solutions. And then they asked me to list all of my solutions, which for this problem would be the same. But the reason they do that is maybe I only got one real solution and the other 2 were imaginary. And so I would have only been able to find one of these possible rational roots because the other 2 were imaginary. So they're just reiterating to me here that, hey, if it's rational, it will be in this list. But if it's not, then you would find it down here in all of your solutions to see that, okay, it was a degree of 3. I did get 3 solutions. But you're not necessarily going to find all of them in this list. So for this particular problem, yes, I could have just gone through and plugged in all 8 of these numbers, and I would have found my 3 solutions. But if 2 of these solutions had been imaginary, that wouldn't have worked, right? Okay, so let's look at another one. Something else about this is that if I graph this, remember that solutions, roots, zeros, x-intercepts are all the same thing, right? So if I graph this, I got solutions of 1, 1/2, and negative 3. And sure enough, you can see I have an x-intercept at negative 3, at 1/2, and at positive 1. So for this test, I'm going to allow you to have your graphing calculator for this problem. So here's how that will help us. I can look at my graph before I start to know what route's going to work instead of having to track all of the possibilities. Let me show you what I'm talking about. Okay, so here's a new problem. So to begin with, I'm going to graph it first. If I graph it first, I can see it's a degree of 3, but it only has one x-intercept. So what does that tell me? Well, that tells me it has one real solution, but that the other two are not going to be real if they're not showing up on the graph. They're going to be imaginary. So I'm not going to be able to find all 3 of those solutions by just trying every possible rational root that is available. The other thing it tells me is, yes, my factors of -8 are 1, 2, 4, and 8. And again, they can be positive or negative because you could have a +1 and a -8, or a -1 and a +8. My factors of Q are just going to be positive and -1. So when I go through and I put each of those P's over Q, I'm going to get those 8 possibilities. All right. So I typically start off by like plugging in 1 and plugging in -1 and plugging in 2 and plugging in -2, right? So I plug in 1 and I get an answer of -5. So what does that mean? Is it a factor? No. All right, then I try plugging in -1 and I get -15. Is it a factor? No. Then I plug in 2 and I get 0. Is it a factor? Yes, because when you get a remainder of 0, it is a factor. But if I had looked at my graph first and saw that I had an x-intercept at 2, I would have started with that value, right? I wouldn't have wasted my time doing the 1 and the -1 if I knew that I had an x-intercept at 2, and so therefore that was going to be a factor. So again, you will have your graphing calculator on this portion of the test. So the first thing I would do is graph it, and I would just skip straight to the 2 and plug it in, and then it would work and save me some time, right? Okay, so I'm going to do synthetic division with my 2. So again, the k goes in the box, leading coefficients across the top. Bring that 1 straight down, and then 1 times 2 goes in the next column, combine. 0 times 2 goes in the next column, combine. 4 times 2 goes in the next column, combine. And then I have an answer of 0. All right, so what are we going to start with right here? Always 1 less than the degree of the polynomial, right? So since it was a cubic, we're going to start with 1x squared plus 0x plus 4 with a remainder of 0. Okay, so now I know that that cubic that I started with, I divided it by x minus 2, because remember this is k, right? So x minus k is what we put in our synthetic division. So x minus 2, and then the answer that I got was x squared plus 4. So now I took that cubic and I broke it down. I could set each of those factors equal to 0, and then I'm just going to solve each of those pieces. So for this guy, I'm going to subtract 4 from both sides, and then to get rid of the square, I'm going to take a square root. Don't forget to put in your plus or minus, and I'm going to get plus or minus 2i. So just like we thought, there was only one real solution. So that also helps us understand why they ask us to write our answers this way, because the only real solution that I got was 2. And it was rational, so therefore you can see it's right there in that list. But if I had tried positive and -1, 2, 4, and 8, I still would have only gotten 2 because my other 2 solutions were imaginary. I have to do the synthetic division to break this down to a quadratic that I can solve to get my other 2 solutions. So now I can list all 3 of those solutions, and it makes sense why this was a degree of 3, that I did genuinely get 3 solutions. It's just that only one of them was real. Now, there's a reason why they taught us this method as the very last way to factor, because this is obviously the longest, hardest way to do it. You want to try everything else in your bag of tricks before you try this, right? Okay, if you have 4 terms, what's a way that you can factor that? By grouping, right? So before I launch into all of this, the very first thing I want to try is grouping. So I'm going to group my first 2 terms and my last 2 terms. I could take an x squared out of these first 2 terms, and then I could take out a positive 4 out of my last 2 terms, and I would have x minus 2 left. Now remember, these have to match in order to do factoring by grouping, and they do. So I'm going to take out that common factor of x minus 2 and then cover those up. What I have left is x squared plus 4. Y'all, that's the same thing that we had right here after we did all of this work, right? So again, this is the longest, hardest way of doing it. You always want to do it as a last resort. Try everything else that you already know first.